Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. We present about the wastewater treatment plant for Maize Cone Farm. We will present about the introduction, problem statement, methodology, result and discussion, and the conclusion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Rabbani bin Abdul Latif. My metric number CF180031.
First, for our topic for this project is wastewater treatment plant for maize or corn farm. For introduction, maize starch is the major industrial raw material for glucose and fructose syrup production in the US and in major other part of the world. Each different technique are used to treat the wastewater before discharging as anaerobic or aerobic degradation or electrocoagulation. The main objective of this investigation is to treat the waste effluent and maximize water consumption by recycling portion of treated water to reuse in washing step or elsewhere. The waste effluent for processing product from fresh maize containing substantial amount of protein. Its proposed treatment unit present an effluent and low-cost industrial wastewater treatment plant to meet the required effluent standard. So our problem statement: agriculture often put great pressure on nature and the environment. Sustainable agricultural practice aim to protect the environment, conserve the earth's natural resources, and maintain and enhance soil fertility. We emphasize crop interaction at three levels of the corn value chain. First is pre-production, such as land clearing. Second, production such as fertilizer, water, and the use of other inputs. And the third, post-production, for example, waste disposal and crop storage. So our problem statement is, in each processes, we identify the environmental limitation on corn product, such as poor soil quality, water scarcity or crop pests, as well as environmental effect from corn product such as soil erosion, water thinning or chemical pollution.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ridzuan bin Bukhari. My metric number is CF180041. For my part, I will explain about literature review and methodology. For literature review, wastewater arising from maize processing industry is rich in protein, ammonia acid, carbohydrate, and nitrogenous compound. Besides, can increase the country income through the cultivation of this corn farming. Example, in Malawi, corn farming industry account for more than 92% of Malawi agricultural land. The maize processing industry is one of the most common food industry worldwide. Even so, discharging of such wastewater to the main water body without proper treatment create environmental risk. Therefore, for methodology, various methods that have been studied and practiced from various places and contribute to country. Improve wastewater from corn wild in the southern plain. Calibrate the CERES corn maize grow model purpose to reduce groundwater use and avoid pollution by reduce maize processing wastewater contaminant by indigenous microorganisms. That's all. Thank you.
Hi, my name is Nizar Asyraf bin Supri. My metric card number is CF180055. I will explain about the result and discussion. So, the design of wastewater comes from information result in analysis of wastewater and the experimental laboratory and bench scale for two effluent streams. So, first, the process description is buffer tank. The buffer tank is designed to receive the industrial wastewater coming from the lift pump station. It is designed with the suitable capacity, complete with the transfer pump and the accessories. Second process is conditioning tank. The conditioning tank will need to have a wet volume of 125 meter cube. We have assumed that a separate acidification tank is not required, so a hydraulic retention time of approximately 0.5 hours based on the design feed flow to the reactor is sufficient. Then the process description for biobed reactor pump. 2 centrifugal pump with a capacity of 252 meter cube per hour each will be required to feed the conditioned wastewater from the conditioning tank to biobed reactor. Next process is biogas handling. The biogas production will be measured and used to prevent overloading of the plant, and it could interlock with the conditioning tank feed pump. Next process is anaerobic sludge holding tank. To enable a quick restart of both reactions, a 350 meter cube wet volume anaerobic sludge holding has been taken in the design. The tank has sufficient capacity to store approximately about 17,500 kg of organic biomass, which is sufficient to replace the content of sludge in the reactor in emergency cases. Next is aerobic activate sludge process. This unit is designed to achieve the aerobic biological treatment contact between the effluent from anaerobic plant and the bacterial growth to achieve the removal of the organic material from the anaerobic effluent. Next process is setting tank. The tank is cylindrical in shape with conical bottom and radial flow from the control slitting chamber to the perimeter. The inlet is a pipe enter the stilling chamber and the outlet is a perimeter overflow where the tank bottom is inclined by 45 degrees to the hopper bottom area that is equipped with outlet pipe for sludge removal using centrifugal pumps. Next process is sludge holding tank. This tank is designed to achieve the additional sludge stabilization to decrease its volume. The unit consists of a rectangular tank equipped with air diffuser and receive a sludge from the final setting tank for sludge storage period. The effluent sludge is thickened and its volume is reduced to 50% of the influent. Next process is sludge dewatering system. This system contains of a picket fans. This system consists of a picket fans, sludge thickener with a rack and gearbox, centrifuge with polymer conditioning and control for sludge dewatering to 15% with capacity of 15 meter cube per hour. So for the conclusion, the recommended treatment of NCMP wastewater effluent is suitable due to its high performance. The specification of treated wastewater fulfill the requirement of government regulation to discharge in sewer network system. The organic compound present in the wastewater are largely degraded by anaerobic sludge treatment and converted to biogas, which can be used as fuel for the plant's steam boiler. The anaerobic system, which reduces the organic water pollution above 90%, allows modern investment and very low to negative operating costs. Whether anaerobic system is economically depends on the amount of biogas the system produces. So that's all for our group 7. Thank you.